Yeah, that's not good. We have a bad line output transformer, and yeah, I've been out and I bought some white spirit, so just submerge that. Oh, yee. What a foul and horrible job. Yeah, if you're coming here expecting this to be a complete how to repair a line transformer or rewind one, don't go a bundle on it, because it's you and me learning together. I've never done this before. Let's just see if I've got anything between the top cap and those two there. So that will be our 463 ohms. Yeah, okay. No, open, open. I reckon that's fairly conclusive. I have got some measurements. So, next thing to do, I suppose, is take it apart and see what we can find out. Can I... Oh, I can. Oh my goodness. Well, that's completely surprised me. I thought that would be stuck. Not keen. It's not keen on moving at all. The jar of joy. I shall put that back down in there. Just in there to soak for a while. Right, see you in a few days.
And now it's time for the latest exciting episode of Doz's Television Workshop.
Right, it's not days later, it's but minutes, because I thought I'd try an experiment. So here is our EHT overwind, and I've got it hooked up to the scope to see if it would ring, to prove it was all right. And as you can see on the scope trace, it's ringing like a bell. Here's the other interesting thing. If I drop part of the core in there, you can see the frequency sort of changes a bit as we introduce a little more magnetic material. If I put, oh gosh, this worries me. This one is coming apart. But if we put more magnetic material in there, let me put that one down, grab hold of this. There we go. We put more in there, rings even better. Look at that. So that's good news. Our EHT overwind is actually serviceable. Brilliant. Right, we're back to the waiting game. See you in a bit.
Much later.
Well, it's been more than just a few days. It is, in fact, been the best part of 2 months. Other stuff got in the way, as it always does. So here is the transformer emerging from its jar. I am just going to sort of put it in this little stainless thing here. Oh, we've got lots of vileness that has come off now. Oh, that is good news. Okay, come on. Yeah. How did I get that in there? I need to engineer my way out of here, don't I? Okay, pick it up that way. There we go. I'm just going to drop that in there. Try and keep the mess off the bench as much as possible. I am wearing gloves because it's just horrible, isn't it? Right, let's get the jar of white spirit. Oh, you can see that. You can see there's a goo of pitch left down the side where I've just scraped it there. So good, that's out of the way. So I'm just, in fact, I'm going to put a bit of paper in the bottom of there, and I just hope these laminations come out of the bottom of our coil. Now those two L-shaped laminations, they look to be coming apart a little bit, so hopefully that will just push out of there now. Oh yeah, there's a little bit of movement there. So that is good news. Right, I'm just going to leave that for 5 or 10 minutes to sort of drain, and then we shall get on to cleaning it up a little bit more. Yeah, and then what I plan to do is start taking the coils apart and counting turns and measuring the wiring diameter. Right, let's wait for that to dry out a bit. Right, sort of got the worst of that drained off. Don't know why I'm thinking of protecting the bench here, but bench is grubby enough, but there it is. And you can see we've got a lot of pitch that's finally given up the ghost and fallen off. So that's good news. Now the trick we need to perform here is to remove this coil from here, and I need to preserve this bit of wiring there really. So yeah, let's get this off here. Oh, it's a filthy job. I've got a feeling it's only ever going to get worse. So, got 3 wires there soldered up to those eyelets. What I need to be careful of, I suppose, is to mark them up. I'm going to attempt to desolder them. So, yeah. Let's grab a pair of tweezers and just see if I can't unsolder that from there. What's the flash point of white spirit? You can see the white spirit sort of evaporating out of there. I think what I'm just going to use is a little bit of braid just to take any of that solder residue away and get muck all over my braid container while I'm at it. Not ideal. Ah, that's interesting. Now, this is why I wanted to pick this apart. This one actually has 2 wires in it. That's good news. It's that sort of information. It's absolutely critical. Right. Put that back out of the way. And just pull these through out of our cardboard piece. I don't know if it's cardboard, it's some sort of card material there. Okay, there we go. Now I need to push these laminations out of the way, and they were yes. Oh, that's fabulous news. That is what I need. So hopefully we can now just ease the laminations out and extract the coils. It's only going to be 2 coils in there, isn't there? So 3 connections, one with 2, 2 with 1. So it's going to be 2 coils of wire. And that's it. There's my lamination removed. Here's my very horrible bit of cardboard. That pitch really is in everywhere, isn't it? I don't think I'll be re-insulating with pitch, by the way. I think I shall use a high voltage varnish and Kapton tape. So, yeah. Right. There's the coil, look. So we've got those two there, which I think are our heater winding for our EHT rectifier. And then we've got the 3 wires itself and a layer of tape. This is sort of exactly what I wanted to see. So that is some good news. It's vile though, isn't it? Let's just see if we can't scrape some more of this off. I don't know as I want to be using my tweezers for that. Let me engage a spudger. I mean, it'll all clean up, but be better off with a spudging tool, I think. Yeah. The more information we can glean about how this thing was made, the better chance we've got of it going back together. That's interesting. This square former in the middle, it seems to be exactly that. It's a square former. So that is obviously what our windings are wound against. Now that wire there appears to be going into the middle. So that was our 3rd wire along. I just want to make all these notes on camera because, you know, even if I do a time lapse of this occurring, I want to be able to put this all back the way it came out. That's taped, so that's interesting. Where does that winding end up? That winding is somewhere near the centre as well. So this is also somewhere near the centre. They're all near the centre. I wonder what that tells us. Hang on, we've got 2 on one end, haven't we? So why have I now only got 1? This one here, despite the fact it looks like only 1, it is 2. Are they all 2? No, I don't think they are. Okay, let's peel some of this. It's like tape. I don't know. It could be paper that's just impregnated and burned over the years of heat and soaking in white spirit for months on end. We've also got that winding there. I got 5 windings. This one is coming out near the edge. These 2 are near the edge. Yeah, these ones are more near the middle. Alright. You have to forgive me if I'm repeating myself a bit here, but you've just seen the first part of the video and I did this months ago, so I'm just sort of reminding myself. Looks to me like there's a bit of a folded piece there maybe, or is that where that's come away? Very difficult to say. Try and wipe a bit of this excess off. Okay. And it's all flaking away. Is that a good thing? Not seeing any wires yet. This is just paper. Another layer there. Let's just wipe this off again. See if I can find where the next layer starts. Oh, there we go. Might have been one continuous piece, and it's just so thin and damaged with the soaking it's had and years that it's just peeling away. Just looking there, I wondered if there was a piece of wire starting to show through, but I don't believe there was. Whoa! Slippery little fella. Right, there is the start of a winding. Fascinating. It only appears to be a few turns round the sort of midriff of the transformer there. Now, presumably as that's on the outside, it must therefore connect to one of our wires. It's only a few turns as well. That gives us a clue that it's the EHT rectifier winding. Because it's low voltage, quite a high current for what it is, and yeah, that's what that is going to be. So my guess is it's these two wires here. I think I've got to stop here and clean this up some more, because I can't really see what's going on in there. Yes, yeah, it's definitely those two leads there. So right, what I'm going to do is I'm going to get myself some fresh white spirits, put it in here and just clean that up as best I can. Right, this I may wish to keep, I may wish to reuse it, I'm not sure yet. It's only a bit of cardboard, and I'm wondering if we could 3D print something nice and thin with some nuts and bolts as terminals, maybe, don't know. We'll come back to that. The laminations obviously I need to keep. Now I'm just going to put a zip tie around those to keep them together, because where the other ones have sort of dried out, that have been the ones we got separated weeks ago, they have fallen to bits as they've dried out. So I want to avoid that happening with these, because I want to keep the stacks together. I know where the other ones have gone, we're all right, but yeah, let's just put a zip tie around there so that lot stay together. Put those out of the way. We're keeping that. This lot go in the bin. Went all the way outside to look for the white spirit. It's in the workshop all along. Right. Just pour a little in there. I've got the window open for some ventilation because yeah, smells horrible. Right, bit of an old toothbrush. Let's give it a scrub. See if we can dilute a little bit more of this pitch out of the way. It's amazing to think, really, that the heater winding for the EHT rectifier, it's probably up at 6,000 or 7,000 volts, and there it is, just insulated with paper and pitch. Of course, usual caveats apply here. This stuff is flammable. I believe in America it's known as Woods alcohol. I could be wrong, but here in the UK we call it white spirit. It's the sort of stuff you usually use for cleaning paintbrushes. Now you can see our winding is starting to become exposed. This will be sort of a bit of a milestone, really, this first winding. I know it's only the smallest one on the transformer, or probably, anyway I'd imagine it would be. And judging by the thickness of this coil, imagine it will be, but nevertheless a milestone. I will need to find the appropriate grade of magnet wire to make this happen, so I want to get all that pitch off there just to make sure the winding comes apart so I can count the turns. You know, if I break a turn off, it'll just make my life a little more difficult. Not impossible, but just a little more difficult. The other thing we could do is completely eliminate this winding, not have it at all, and fit a semiconductor rectifier as I did on the Pi 169 and the Philips set recently. Makes for a little less heat in the set as well, but not by much. Nice to get it original if I can. If I hit a problem, well, we hit a problem, don't we? see it's nicely tightly wound on there. So, but it's only what, 6 or 7 millimeters deep that way, maybe 8 millimeters, not a lot. Right, another bit of paper. Going to use a lot of that, I think. Right. Let me just put that out of the way. Okay, so all the windings I'm going to make with those 3 terminals at the bottom. So, can I pick this first winding out? I can. So, 1 turn, 2 turns, 3 turns, 4 turns, 5 turns, 6 turns, 7, 8, 9. Oh no, I'm stuck. So that's 9 turns. Or is that 10? Did it complete the third one? It did. It's 10 turns. So we have 10 turns on our heater winding, 3 at the bottom, there. So that is 10 turns. Heater's coming out opposite the 3 at the bottom, down here. So they come out there. And that, of course, will be the last winding we put back on. So, right, I need to write that down, and it is going from right to left, top, down. Those are the details I need to record. What I'd quite like to do here is go and get a bit of old cardboard, write it down, and then I'm going to cut a piece of this wire, sticky tape it to the cardboard, so I've got a record of the gauge of the wire as well. Right, I'm going to find something suitable to do that. Right, I've got a bit of an old record mailer here, so I'm going to attempt a drawing. So this is the heater overwind, and we have 10 turns, and I'm just going to draw the spool here, which is our double wire, one on the left. Okay, it comes in here, goes off that way, like that. 10 turns. Well, it is a diagram of sorts, isn't it? That'll do. I'm just going to snip a bit of this off, and then stick that there, so I've got a record of what it was, because I'm going to need to measure this wire, probably with a micrometer. I'm not quite sure where my micrometer is, but yeah, so if we stick it there, we've got a record. So we've only got 4 coils left to do. We've got probably this one here, and then this one here that's Siamesed up together. I bet that's the other end of that. So yeah, these are going to be a lot more difficult to do, though. This is just the start. This is the easy bit. This is 10 turns. The next one may well be hundreds, and probably will be hundreds. So yeah, there we go. Don the gloves again, and repeat for the next winding. I think I need a bit of a jig to make this a bit easier. Right, thinking about something to sort of hold everything together. This is my PCB vise, and I've just popped the jaws off. Just a little circlip, one either end. And yeah, there we go. That's something I can hold it in. So that's good. And then I found a piece of 5mm diameter aluminium rod that seems to want to fit in there, so that's good. And then I thought, all right, I need a former to hold the transformer bobbin steady, so I've 3D printed that. You can see there's a hole down it. So the idea is that I'm actually going to interference fit that, so I'm going to tap that through the middle of there. This will then fit the bobbin on, look, and I've got something nice I can just use to hold everything in place while I count the turns. And because this piece, I printed it that way up, it took about 2 hours. And whilst those 2 hours were ongoing, my brain started working. So I've 3D printed some more stuff. 3D printed a little handle to go on the end, so I can sort of watch the handle rotate, and maybe might be useful for rewinding. And I've 3D printed a couple of these. And the idea is these are going to fit 90 degrees apart, like that on there. So you can see I've got 2 quadrants. And the idea is I'm going to have some photo interrupters looking at each quadrant. That way I can work out which direction I'm turning it in and count the turns, and these 2 quadrants should debounce the signal for me. Throw that into an Arduino and it'll count the turns for me. Not only that, but I should be able to count this at some rate. So if it works out, I could probably even get hold of the wire and just pull and let it spin like the clappers, and it will give me a count at the end. What do we think? Do we think this is a sensible idea? I suspect I'll end up putting a hole in there so I can anchor these down with a screw, and maybe turning that one round that way, and then I can use sort of this area here to clamp the bobbin in. So bobbin can sit in there and we'll count the turns that way. Now I've got as far as this. I've written a bit of code. I'm just not happy with the sensors I've got for these quadrants there. They are very heavily affected by ambient light, so not very good at all. So I've just ordered some more, so I'm just going to come back to this and see if we can get it to work. Just goes to show how these jobs snowball, doesn't it? Right, I have created a coil counting piece of kit. I'll just explain how it works. In here we've got obviously an LCD display there, and we have got a SparkFun Pro Micro Arduino board in there, and that's connected up to these photo interrupters. I have some spares I will show you. So what this is a little U-shaped device there. Takes 5 volts or 3.3 volts, has a transmitter on one side, an infrared transmitter on one side, and a receiver on the other. There's a little chip on the bottom, probably just some sort of pulse shaper, don't know. So yeah, we've got a transmitter on one side and a receiver on the other, and obviously when the beam is shining through, I think we get a low output, and then when the beam is broken, we get a high output. So there are 2 of these sensors underneath, and I know what you're saying, why have you got 2, Doz? I've got 2 for a very good reason. So they've got these quadrant shapes, and you'll notice here there's some aluminium tape stuck to it, and that's because it turns out that the grey PLA I printed these in passes infrared perfectly. So when the paddle is actually in between the slot of the detector, when it's in there, the detector doesn't see it. It's like it's not there. Magic. But that's infrared for you. So I put some aluminium tape on there just to completely block that infrared. And what happens is you rotate it once and it counts. We've got a count of 1. And then 2, 3, 4, 5, etc. And what it's doing is the first paddle counts, so that increments the number of turns, and the second paddle, what it does is it stops the counter incrementing accidentally. So like a switch bounce, if I'm not very steady with the rotation, it might jiggle through the beam, and one pass could end up being 2 to 20, 30 on the display. So this prevents that bounce. So yeah, there we go, 8, 9, 10, 11, 12, etc. And I have tested this by wrapping a number of bits of string on there and then pulling it off quite quickly, and it gets it right every time to within 1 turn. So I'm really pleased with that. That should be good enough. So what I'm going to do is I'm going to mount our bobbin on there, and it should allow me to quite quickly wind the turns off, get an accurate count, which I can then note on my piece of cardboard, and completely map out our winding schema. Right, let's make that happen. First things first is to mount the bobbin. So you just slide that out the way. This should just slip on there. That's good. I'll get all the wires out of the way a bit. Slide that back in. This is quite good. This is giving me, some good surface to want to sort of work on. I am just going to don my gloves again, because it is still covered in pitch and horribleness, and peel off the next layer of paper insulation there. This, by the way, only ever counts in the upward direction, so it doesn't matter which way it goes, and I shall reset it obviously before I start unwinding wire. the next winding to get exposed is actually this one here. Oh, I have just exposed the first winding. Sort of seems to want to feed into the middle there. Let's just see if we can't peel a bit more of this off. That's a lot of paper. It's taken a good few minutes to peel all this off. Yeah, there is the end of the winding is just in there. So let's just remove this last layer of paper, I think. Oh, there it is. Don't want to risk breaking it. I would have thought they'd use the same gauge wire, leaving the winding as they did on the input to the winding, but it doesn't appear to be the case. I think they've joined it. Outside wire is thicker than the inside wire. Okay. I think this might need yet another soaking, just in something to lift this bit of paper off. These tweezers are sort of quite sharp, but don't damage the coil itself, otherwise I will never count it off. There it is. That's actually the coil there. Okay, I'm going to take it off and I'm going to get myself some... Do I need fresh stuff or shall I just use that? I think I'll just use that and try and soak a bit of that off. I'm not interested in counts at the moment. I know where I am. Just take it off there and try and clean some more of this unpleasant pitch away. They've obviously insulated on the top of each layer, as well as just with this sort of tissue paper. Right, I need a cup of tea. I'm coming back to that. There seems to be quite a bit of pitch on this piece. which is making life a bit interesting, shall we say. I have a feeling this winding is of some sort of depth, so presumably it's a multi-layer winding, which is sort of what I expect. So I'm going to have to count each layer off individually, and then hopefully there's not too much insulation between each layer. Whoa, I've just disturbed that first turn there. I'm going to put it back. Yeah, that's coming away, and I don't want that to happen. Don't make that happen. I think I'm going to put it back on the winder and have a look at it. Let's just dry it off a bit. So, winding started there. So where are we on the count? I'm just going to reset that by repowering it. And then I think I'm going to start unwinding. So just coming up to our first turn there. Yeah, and I'm in the insulation. Okay. Picking away at it, I suppose. It's just getting quite difficult. I was hoping I'd sort of be able to cheese wire my way through the insulation, but I don't think that's happening. Oh, I don't know. Yeah. That is working well. 6. That's 10 turns. You see there's a horizontal piece of material where the original winding sort of started and ended there. Or started. Or actually that'll be the end, wouldn't it? It's the piece we put on last. So, okay. Seems to be a linear winding, it's not bunched up or anything, just seems to be one layer of wire laid flat there. So I'm going to try and peel a bit more of this away. I suspect it's going to end about here somewhere, so 58, 59, and it's at the top we started, so that's where I want to end. Oh, there we go. So that is 60 turns. Right, I need to write that down. And I'm going to draw this up the other way, and then I'm going to keep the bobbin the same way when I go to rewind it. So this is our first winding, which comes out of the top here. So I've got our 3 down here still, and it's this one here, and our first layer is 60 turns. Okay, let's pick at this insulation a bit, see where we're going next. It's a nice round number. I'm sort of a bit encouraged about a nice round number. There is of course no reason why it would be a round number, but well, it's encouraging to me. I think if I was designing a transformer, I think I'd have an even number of turns, or a whole number of turns. What I may just do is snip this wire, wind it up on my hand. It's like human hair. I'm going to, so that's my first layer. I've obviously got to measure the diameter of this wire. I have managed to borrow a micrometer, so it looks to be 0.01, 0.019, something like that. Just from the feel of it, I may be wrong, but we shall get onto scientific wires later on, and hopefully order a bunch of this stuff so we can make our transformer right. Yeah, you can see the transition there between the lead out wire and the winding itself. So that is our first layer. I'm going to tape that onto the board in a minute. Right, let's have a look at this insulation here. Very crusty. I'm going to want to reset the counter in a minute anyway, so I don't want to peel off any more turns. There is. Ah, that's where it leads in, I think. Okay. So it's 2 turns of lead in. Maybe. Not seeing the whole winding yet, so let's keep counting that. $63. 64. 64. We won't put it together. We're exposed to winding now, look. So that's good news. So yeah, there are sort of 5 turns there in between the 2 windings. Now I need to pick this insulation away so I can expose the whole length. And this I intend to replace with Kapton tape. I need to move that without moving it. Oh, stressful. Again, there's a lot of pitch in there, but I don't think that's doing us any harm at the moment. It's sort of sticking the wiring together, so I'll leave it. It might do us a favour. Right, so that is 65 turns there. I'm going to reset the counter and add 5 turns onto the next layer. So yeah, we just reset the counter and we are away. So we've got 5 on there at the moment. So and that's the end of that winding. 116 plus 5. 116, that's 116 plus 4 is 120. Yeah, I reckon that's probably, so we got 2 is 121. Betcha that's 120. Betcha. $118. It's looking pretty consistent, isn't it? So 118. Try and hold that steady. I almost want a sort of lock-in device just to hold it in while I remove the interlayer insulation, really, but we don't have that, so once again 118, and then by the time we've removed the insulation we're getting to 120. So layer 4, and I'll bet you that's plus 2. So let's just pull the insulation away. Oh, okay, that's interesting. What's just happened there? It was 100 turns, and there's something going on. Right. Nine. And this is odd. 100 turns. And then we've got something bizarre going on under the insulation there. Let me put my gloves back on. Don't know why I took them off, really. Ah, I think that's the exit splice. I think. So there's 9 layers, each of 120 turns, except for the first one and the last one. I think this should be one of our pairs of windings. So let me just gently fetch this out. Or is it just a splice? Did they have to splice it for some reason? No, that is the end of our winding there, and the start of a new winding. Okay, that's the end of that winding. And then we are on to, that one no longer exists, this one, to wherever that goes. This was clockwise when it's unwinding. Right, wow, gosh, exciting stuff. Exact numbers, more or less. I'm pretty convinced that we've got 120 turns a thing there. Let's get this nastiness off there. Okay, so where's that wire gone? It's that one there, isn't it? It is. So that leaves us with the last winding then. Or does it? Now hang on. No, I've got one snapped off, haven't I? It's okay, we'll find it. I may need some magnification here. There it is. I think. God, that really does look like Kapton tape. That's what I'm planning to rewind it with. I should have 3 wires left at the bottom, and I've only got 2. So I had that one came down to there, which was on that piece. So where's that one going? It must have been spliced on in here somewhere. Well, we'll find out if I take it apart layer by layer. Looks to be a much thicker wire on this next winding, which will make my life a little bit easier, I suppose. Notice how much darker it's getting as we go in. The tape started out quite sort of translucent, didn't it? But it's got darker and darker, presumably because the thing's been hot. That's good. Oh yeah, and there. This is really charred and horrible in here. This is clearly our primary, I would imagine, being it's got a thicker sort of winding to take a bit more current maybe. Definitely looks like Kapton tape. Huh. Did they have Kapton in the 50s? Okay, there's our wire, and it's the middle one. Middle one is the top. There it is. Okay, and it actually runs out on the splice. So I'm just going to reset the counter. I'll have a go at taking it away. Counter is on 0. Okay. So that's 55 turns. And let's see how much under the tape we've got. Oh, the tape is not behaving well. Right, I think I'm going to stop here. Just have a cup of tea for a second. Okay, I have taken the last winding off, just off camera. And the voting is in. 65 turns was on the last one, and then roughly 70 turns per layer there. So now all I've got to do is this is all the wire that came off the transformer here. I've bundled it up because I want to weigh it, because when I buy wire, you buy it by weight. Now I know this is these 2 windings, the second and third windings together, but let's face it, I'm going to want a bit more than that. So I'm going to weigh that, and that's the amount of wire I'm going to want to order plus a bit, whatever the nearest minimum order quantity is. I shall be using the Scientific Wire Company for purchasing my magnet wire. They're an excellent company, nothing more than a very satisfied customer. They can be found at wires.co.uk, a most excellent company to deal with. So I need to measure my wires. I should be measuring that with the micrometer. I should be cleaning up all of this rubbish. In fact, I think that's what I'm going to do first, because everything is filthy. Everything stinks of pitch and white spirit and general unpleasantness. So I'm just going to have a tidy up of all this. I'm going to soak that. Let's do that first. Let's take the bobbin back off. I think I might reuse that. Could 3D print a new one, but not sure I see the point. So I'm going to drop that in there. Clean that up. Yeah, and just go from there. I'm going to clean the rig up again before I use it, but we are done with that for now. So that can come out of the way. That's been very good. I've been very pleased with this. It did make life a bit easier. And I'm all for having an easy life. So that was well worth, you know, the couple of days it took me to just design and build it. So I'm really pleased with that. Let's just get all this nastiness off of here. Right, first things first, we'll do the easy bit. How much does it weigh? 50 grams. So 52. Not a fat lot. I'm going to write that on my sheet. I'm going to find a pen I haven't abused. So, I mean, that's for almost all the wiring. So if I order, you know, I think I have to order half a kilo. So I'm going to have plenty of wire to be going on with. I may have some of this diameter. I don't know yet. There is a reel in my stores. So yeah, next thing to do is just to clean that up a little bit and attempt to measure it, which means I need to remember how to work a micrometer. That's 0.1 of an inch, isn't it? So it's in American freedom units, unfortunately, and I do seem to remember this one being 0.1 out. It is... maybe it's okay. Anyway, right, I'm going to clean this wire up first. I'm going to choose a bit of IPA just to get the sort of pitch off the wire, so I get a decent reading. There we go. So try and find a straight bit and just measure its diameter. So that is measuring 12 on my dial. I'm going to have to remember what that is. I think, isn't that 0.0012? It could be there, it could be there, couldn't it? Can't remember. We'll see what that translates to in metric in a second so I can get my head around it. Said I wasn't going to use that pen, didn't I? let's clean up this piece of wire. This is much finer. You can see where it's been hotter as well, actually, because this stuff has cleaned up nice and copper coloured down here. Just off camera there, you can see that. That's nice and shiny, that bit. This stuff up here, it's been hot. I wonder if that's where our short was. Right, let's see what size this is. It's probably machinists and everybody telling me I'm doing this wrong somewhere, and you'd be right, to be quite honest. A machinist I am not. Right, that is measuring 8, whatever that is. I'm not worried about this heater winding. We've just got to find something that'll go on there. So is that 0.08 of an inch? It's knowing, isn't it? So that's 0. So this is 12. Let's measure it again. Exactly 12. This one. Yeah, just over 8. So it says 0 to 1 inch, 0.0001 inches. 0.001. So yeah. So that might be because that stuff's thicker. So that's got to be 12, and it's got to be 8. Is that 8 thou? I don't remember. It's been a long time since I've had to work in imperial units, but we've only got an imperial micrometer. Okay, so we need 52 grams. I'm going to translate that lot now into metric, and yeah, let's see what that comes out at. Right, 0.012 turns out to be 0.3048 millimeters, and 0.0008 in an inch turns out to be 0.2032 millimeters, which, to be honest, that looks about right. So I need to order up some of that and some of that, and yeah, we'll go from there. Right, that's going to do it for this episode. I'm going to get onto wires and order my stuff up. And I have ordered already a roll of Kapton, which I'm going to use to insulate in between my layers. And the beauty of this is, the diameter is exactly the same as the diameter, the length of our spool piece. So this was just the job. And then once the wire has arrived, it's time to get on and rewind it. So anyway, thank you very much for watching. Click like, subscribe, do all that rubbish, and pop back soon, and we'll spend hours rewinding the damn thing. Cheers now. Bye.
At Dozie's workshop, he's a glove. CRT screens, the static shock. Sold the